So to find the probability in a normal distribution, we will have to transform a normal random variable to a standard normal random variable by finding the z-score. Then once we find the z-score, we will look into the standard normal tables to find the probability. I'll show you how we can browse through the standard normal tables in the next slide. But before that, let's see what is the formula for z-score. Z-score is given by this formula. Here x is the sample observation, mu is the mean, and sigma is the standard deviation. Now the next question is, once we find the z-score, how do we interpret it? So a z-score of 1 means that it is 1 standard deviation above the mean. A z-score of 2 is 2 standard deviation above the mean. And a z-score of say minus 1.8 is minus 1.8 standard deviation below the mean. Now once we have z-score, we can find the probabilities using the standard normal tables. But before that, let's see how we can use z-score. Suppose we have got the scores of a group of students. Now let's say the mean score of this group of students is 60 and the standard deviation is 15. Then let's say we have a student Sarah who has scored 70. So what does this number 70 tell us? Is it a good score or a bad score? Well, to be frank, it tells us nothing much except that Sarah has scored 70. But if somehow we can know that how many students have scored more or less than Sarah, then this number 70 will be meaningful for us. And yes, we can do it by studying the scores of all the students. But remember, studying the population is rarely possible. And we always study sample to derive the conclusion about the population. And that is the whole point of doing statistics. So here we will calculate z-score from the above formula. And let's say it is coming out to be 0.67. And then we can look this value of z-score in the standard normal table to get the probability. So when we look at the table, we get to know that it is coming out to be 25.14%. Which means approximately 25% people have scored better than Sarah and approximately 75% have scored less than Sarah. So I hope you can see how z-score makes sense. Now the same thing we can show on the distribution as well. So you can see here in the graph, 75% of the scores are on the left of Sarah and 25% are on the right hand side. So that is how we use z-score. Now let's see how do we use the standard normal tables to find the probability using z-score. So in our previous example, we found the z-score as 0.67. Now we will look this value of 0.67 in the standard normal table. So this is a screenshot of a standard normal table. You can search it online or you can find this in any of the statistics book as well. So to find our value of 0.67, we will look in the first column and find the nearest value, that is 0.6. Then we will look at the top row and find the remaining value of 0.07. Now the value at the intersection will be the probability. And remember, that is what we found in the previous slide. Now interestingly, we can also use z-score to calculate x at a given percentile. Suppose you have been given a z-score, mean and standard deviation and are asked to find out the value at 70th percentile. Recall, percentile is a value below which a given percentage of observation falls. For example, 70th percentile means 70% of the observation falls below it and 30% lie above it. So we can use the above equation and we just have to find the value of x, and this will be our value at 70th percentile.